You own a house that has slowly appreciated in value in the 8 years that you've owned it. The value of the house is given at different times in the table below. Use a trapezoidal sum. Do you remember that? There's 4 sub-intervals indicated by the data in the table to approximate the average value of the house during the time interval from 0 to 8. There we go. We need to find an approximation of the average value of the house. Why is it not exact? Because we don't have the formula. We don't have the function itself. So remember this, we've been talking about for the last like 700 videos, or like 3, 4. Anyway, that's what we're doing, but we don't have the ability to really find this. And a really good way to approximate this is with lots of little rectangles or some trapezoids, and we're going to do trapezoids. So even though we can't find this portion of it, we're going to approximate it, and that's why it's called, well, an approximation. So from the very beginning, I'm going to write that formula one more time. The average value is this. The more you write it, the more you'll remember it, the more you'll be able to put it in context. But the problem with this, again, is that we don't know this part because we don't know this part. So we're going to have to approximate it with a trapezoidal sum. So already, very beginning, 1/8, okay? 1/8. Regardless of all the other stuff that's about to happen, 1/8. And then we have lots and lots of little trapezoids. And our trapezoids, lots and lots of little trapezoids. It was hilarious in my head the way it sounded, like there was a daycare for trapezoids. Only 4 actually, so small daycare. And the formula for the area of a trapezoid, in case you forgot, you better not, is 1/2 height base 1 plus base 2. And this is the height. It is 2 or 1 or 2 or 3. And the 2 heights are 110 and 112, and then 112 and 120. So that's what we're dealing with. Draw it if you need a visual. We have gone through several of these, so I'm not going to draw all this again. So we have 1/2. Can I go crazy on you? Nah, I won't. 1/2 height 2. Base 1 plus base 2. There's our first trapezoid. Our first trapezoid goes from 0 to 2. I wasn't going to draw it. 0 to 2, and it has a height of 110 and then 112. So there it is. That's 110. That's 112. And we're going to do that repeatedly. So from 2 to 3, that would be a height of, a height of 1. And it goes from 112 to 120. So there's the third one. I'm not going to draw anymore. I'm going to draw those. So 1/2 height base 1 plus base 2. I'm feeling the ink running out. It's getting tragic. Come on, purple pen. Hang with me. Stay with me. I'm giving out all she's got, Captain. The height of this one is 2. The base lengths are 120 and 131. And again, I know I'm saying height as I'm going this way because we talk about height of a trapezoid from a point of view where the 2 sides that are parallel are top and bottom rather than this. So we're just looking at it from a different perspective. And then 1/2, 3, and that would be 131 and 140. And that closes those parentheses out. And we're actually dealing with the value of the home. So final answer I would say 3 decimal places, but this is money. They would be very specific. They would say to the nearest penny or whatever. So if you typed all that in your calculator, and we are not going to go through all that right now, but if we typed all that in the calculator and wasted your time in a video and you know how to use a calculator, we would end up with 124,437, I've already typed it in, and 50 cents. And that does kind of make sense that we would round it off there, but I think it does truncate there. And so as I look at my answer key, this is what I have. I'd worked this one out previously. And so I have this. Here's what that means. Over the course of 8 years, the average value of my home was $124,437.50 and 50 cents. What's 50 cents in the value of a home, but still. And 124,000 happens around here. So somewhere in between year 3 and year 5, we have the actual one. We could get crazy. My mind just went here. We could go crazy and talk about the intermediate value theorem, how this is a continuous function. Technically, since we have to go up in increments of pennies, it may not be, but we're still kind of dealing with this idea that 124,000 has to happen in here somewhere, which happens between year 3 and year 5. So anyway, I digress talking about the intermediate value theorem. That is that has nothing to do with this, and it kind of has everything to do with this. That's it.